Hi everyone, welcome to my channel SOBASICS. Today we are going to discuss on types of chemical reactions. Most of us will be having a problem on finding products or making some chemical equations, because in chemistry there are lot of chemical equations. So after this session I think you will be much more easier for dealing with them. Now going to the type of chemical reactions, first one is combination reaction. Second one is decomposition reaction. Third one is displacement reaction. And fourth one is double displacement reaction. And the last is redox reaction. These are the types of chemical reactions, that is combination reaction, decomposition, displacement, double displacement, and finally redox reaction. So we will go in detail about all these types of chemical reactions. So first type of reaction is combination reaction. Okay. So from the name itself, it's clear, like combination. So two or more reactants combine and forms a single product, that is two or more reactants. Okay. They will just combine to give a single product. This is combination reaction. That is, consider two reactants. Let them be A and B. So A and B are two reactants. They combine to give a product, single product called AB. Okay. So these two are two different reactants. They combine to give a single product called AB. This is combination reaction and we will be discussing about some examples. First, consider H2 plus O2 gives H2O. This is hydrogen, this is oxygen, and this is water. So, just look. H2 plus O2 will not give H2O2. We are not getting H2O2, but we are getting H2O, which means they just don't directly combine with each other. Okay, two molecules of oxygen and two molecules of hydrogen, but we are not getting H2O2. This is not right. This is the right one. This is because elements just combine according to their valency. Okay, this is the reason for this. Next example, Mg, magnesium plus O2 gives MgO. See, here also again Mg plus O2. That is, we are not getting MgO2, we are getting only MgO. This is also because of the valencies. So here two reactants combines to give a single product. Okay. Next, Na plus Cl2. This gives NaCl. Again, two separate reactants combine to give a single product. So this is what combination reaction means. Next one is decomposition reaction. Second one, decomposition reaction. So this also, from the name itself, it is clear that they are just decomposing. Decomposing means they are just breaking down. So here the reactants will be breaking down and giving products. That is, consider AB, let AB be a compound, and they decompose to give single products like A and B. That is, a single compound decomposes, or they just break down to give two or more products. Okay, that is what we have seen here. AB is just a single product and it just breaks down to A and B. Okay, so this reaction is just the opposite of combination reaction. Now we'll go for some examples. So in combination reaction, we have taken an example, that is H2 plus O2 gives H2. So taking similar same example, H2, water decomposes to H2 and O2. So this is a decomposition reaction because H2O decomposes to hydrogen and oxygen. So a single compound decomposes to give two or more corresponding products. Okay. Next, calcium carbonate. Calcium carbonate decomposes to calcium oxide and carbon dioxide. Okay. So here also single compound. So CaCO3 is a single compound. It decomposes to calcium oxide and carbon dioxide. That is two products. So they are just breaking down and giving more products. Okay. So this is about decomposition reaction. Next type of reaction is displacement reaction. Okay. So here, in this type of reaction, active metals just replaces the less active metals. That is, the main principle is that more active elements displaces less active elements. So you all may be asking that how can we compare the activity or the reactivity of elements? Yes, there is another solution named reactivity series. Okay. This is a series in which elements are arranged in the decreasing order of their reactivity series, which is seen there. Okay. So here elements are just arranged in the decreasing order of their reactivity. Okay. So in general equation, consider a reactant A and another reactant BC. Okay. When reacting both these, we get AC plus B. That is, this A displaces B from this compound and it comes like AC and it just throws out this B. Okay. Did you get me? A here, A is much more active than B. So this A just replaces this B here and it throws out the B. This is what is displacement reaction. We will go for some examples. Now consider an iron nail, okay? An iron nail and add it to a copper sulfate solution. What is the color of copper sulfate solution? Copper sulfate solution is blue in color. So, what did I tell you? Iron nail. Put an iron nail in copper sulfate solution. Okay. The solution, the color of the solution changes to green after some times. This is because what? Because of the formation of FeSO4 solution. The color of copper sulfate solution is blue and ferrous sulfate solution is green. Okay. And copper will be getting deposited as precipitate in red color. So here displacement reaction is taking place because iron is much more reactive than copper. So iron replaces copper from copper sulfate and forms ferrous sulfate and it throws out this copper. Okay. So the color of the solution changes from blue to green. Okay. Now taking copper in ferrous sulfate solution. Okay. Take some ferrous sulfate solution and add some copper. We'll be getting no reaction. Why is this? What is the reason? Because what? In reactivity series, you have seen that copper is less reactive than iron. So copper will not have any ability to replace iron from ferrous sulfate and from copper sulfate. So there will be no reaction with this. Clear? Next type is double displacement reaction. That is fourth one. It is double displacement reaction. Okay. In this, two compounds react with each other and they just exchange their ions. Here, two compounds are reacting, not two elements. Okay. That is, consider a compound AB. Let AB be a compound and CD. Okay. These two are reacting with each other and they just exchange their ions. That is, this is because it is called as double displacement. Only the single displacement means what? Only one will be exchanged. What was the case? A plus BC gives AC plus B. This was the case, okay? But here the case is just reverse, right? AB plus CD. What will be that? They just exchange. C will be transferred here and B will be transferred here. AC plus BD. This will be the product. Okay. So two components are reacting with each other and they just exchange their ions. Okay. I will explain you. Example. Silver nitrate plus sodium chloride. So these are two compounds. Okay. First, write them in their ionic form. That is Ag2 plus and NO3 minus. Okay. This is the ionic form of AgNO3. Then Na plus Cl minus. So here either we have to exchange the anions or cations. Okay. Either we should exchange this with this and this with this. We should not exchange both cations and anions. Either we have to exchange anions or cations. Here I am exchanging anions. Okay. Now what will be there? AgCl, is it? Plus this NO3 will be shifted here. NaNO3. See, Ag and Cl. NaNO3. So this is what means double displacement reaction. Okay, one more example. NaOH plus HCl. Okay, now writing them in their ionic form. Na plus OH minus plus H plus and Cl minus. Okay, these are the ionic forms. So in the first case I just exchanged anions. Now I am exchanging cations. Okay, either we exchange anions or cations, we will be getting the same, but exchanging both anions and cations will give the reactant only. Okay, so that is not correct. Now exchanging the cations. Okay, these are the cations and I am exchanging this Na to here and H plus here. So Na plus Cl minus will give you NaCl plus H plus OH minus gives water, that is H2. So this is double displacement reaction. Okay, that is two compounds combine with each other by exchanging their ions and thus they form products. Okay, and the last reaction is redox reaction. Okay, what is this redox reaction? Before studying about redox reaction, we have to know about two other reactions, that is reduction and oxidation. Okay, so oxidation, from the term itself it's clear. Oxidation means addition of oxygen. Okay, otherwise removal of hydrogen. Okay, so this is the definition of oxidation reaction. So what will be reduction? Reduction will be just the opposite of oxidation, that is addition of hydrogen and removal of oxygen. So oxidation and reduction are just opposite to each other. Now redox reaction is reduction plus oxidation. So redox reactions are those reactions in which both reduction and oxidation takes place simultaneously. Okay, I will explain. Consider copper oxide plus H2. Okay, now what are the products? H2O plus copper. Okay, consider the reaction. Here copper oxide is getting converted to what? Copper. So copper oxide is getting converted to oxygen, means oxygen is getting removed from copper oxide and we are getting only copper. So removal of oxygen takes place. What is removal of oxygen here? It is reduction. So copper is being reduced. Here reduction takes place and copper is being reduced. Okay, now consider hydrogen. Here hydrogen is converted to water by addition of oxygen, which means hydrogen is getting oxidized. Okay, so here oxidation takes place. Okay, so in this reaction both reduction and oxidation takes place. So this is a redox reaction, which means hydrogen is the reagent which helps copper to get reduced. Okay, because of hydrogen, because hydrogen is abstracting oxygen from this copper oxide and becoming water, thus copper is getting reduced. So hydrogen is helping copper oxide to get reduced. So this hydrogen is the reducing agent, and this copper oxide. This copper oxide is helping hydrogen to get oxidized because this is giving out oxygen and hydrogen is abstracting that oxygen and becoming water. Okay, so this copper oxide is the oxidizing agent. So in redox reaction, the element which is getting oxidized is acting as the reducing agent. You get my point? Here hydrogen is oxidized to H2O, water. H2 helps copper oxide to get reduced. So hydrogen is the reducing agent. Then here copper oxide helps this hydrogen to get what? Oxidized, because this copper oxide is giving out oxygen and it has become water, thus it is getting oxidized. So this copper oxide is helping hydrogen to get oxidized. So copper oxide is the oxidizing agent. Okay, clear? Next, one more example. H2S plus chlorine. Okay, what we are getting? HCl plus sulfur. Okay, so here H2S sulfur. H2S is becoming S2, which means hydrogen is getting removed. Removal of hydrogen is oxidation. So this compound is getting oxidized. Okay, oxidation. Then chlorine. Chlorine, Cl2 becomes HCl. So hydrogen is getting added. Addition of hydrogen is what? Reduction. So chlorine is getting reduced. Okay. So what will be the oxidizing and reducing agents? Since H2S is helping chlorine to get reduced, H2S is the reducing agent. And since chlorine is helping H2S to get oxidized, chlorine is the oxidizing agent. Okay, so this is all about redox reaction. Redox reaction is the type of reaction in which reduction and oxidation takes place. Thank you for watching my video and supporting me. For more videos, please just subscribe my channel and like my videos.